Hello, you're welcome. All right, so this is chapter 2 of engineering mechanics. The topic is resolution and composition of forces. So we are going to be looking at problems and their solution. But before then, let's review the important formula and, of course, the analytical method of solving for a resultant of system of forces. Now, the word composition simply means resultant. So the composition of system of forces is a method of solving, all right, for the resultant of the system of forces. There are two analytical methods of solving for resultant of system of forces. One method, all right, is actually applying the law of the parallelogram law of vectors. So parallelogram law of forces, law of forces. Okay, so now according to this law, of course, this law is used for two force, okay, two force inclined at an angle to each other. So let's say you have two force F1 and of course another one F2 inclined at an angle theta to each other. So this is F1 and this is F2. So according to the law, if two forces inclined at an angle to each other is represented in direction and in magnitude by the adjacent side of a parallelogram. So I'm using this parallel side. Okay, please pardon me. Okay, so now I'm using this. I'm using the parallel side to F2 to represent F2 in direction and magnitude. So I'm actually completing the parallelogram. Okay, so here this is represented. This will represent F1. So according to the law, so uh, if the adjacent side of a parallelogram is used to represent the two forces, then invariably the magnitude and the direction of the resultant can be represented by the diagonal of the two forces that is drawn from their point of intersection. So invariably now this diagonal of the parallelogram becomes the resultant. This becomes the resultant of the two forces. Now the question is, how do we calculate for the resultant? So this is where we apply cosine rule. The resultant R is calculated by cosine rule, which of course is given as f1 square plus f2 square, then plus 2 f1 f2 then cos theta, 2 f1 f2 cos theta. So this is cosine rule. All right, now this cosine rule, the Pythagoras rule that is used to solve for resultant of two vectors perpendicular to each other, is derived from the cosine rule. Okay, remember, when two forces are inclined at an angle of 90 degrees or perpendicular to each other, then the angle is 90 degrees, then cos 90 is 0. So in such a situation, you discover that the whole of this term is equal to 0. So we are only left with the resultant equal to the square root of just f1 square then plus f2 square. So this is Pythagoras rule. So when the two forces are perpendicular to each other, we apply this formula, right? Okay, so please take note of that. Now this formula actually is used to calculate the resultant of two forces in magnitude. But what of the direction? Okay, what of the direction of the resultant? Okay, so the direction of the resultants R, let me call it alpha, is the angle that alpha makes with F2. So how do we calculate the alpha? Now, if I should actually extend this line, of course, the F2, you know very well that this is F1. The angle between F1 and F2 is theta. This is theta. So invariably, this angle at a straight line, this angle inside the parallelogram is going to be 180 minus theta. Okay, so now how do we find this alpha, the direction? How do we solve for the direction? This is what, for us to solve for the direction, all right, then we apply sine rule. This is when we apply sine rule. According to sine rule, okay, according to sine rule, f1 divided by the sine of the angle opposite f1, which of course is what we are looking for. F1 divided by sine alpha. We are looking for alpha. Alpha is the direction that we're looking for. So it's going to be equal to the resultant that we know divided by the sine of the angle opposite the resultant. Okay. The angle opposite the resultant, as you can see, is 180 minus theta. So that's going to be sine 180 minus theta. Don't forget sine 180 minus theta. Okay. So from here now, we can actually make sine alpha the subject. Sine alpha is going to be equal to f1 multiplied by sine 180 minus theta, then of course divided by the resultant. So now, of course, you know, for you to be able to solve for this resultant, you have to find the sine inverse of the right hand side of the equation. Okay, so the alpha is going to be equal to the sine inverse of what we have here, of f1 sine 180 minus theta, okay, divided by the resultant. So take note of this. So this is the direction of the resultant, and of course we actually use this for the magnitude of the resultant. Now we are going to be solving questions. Let's go straight to questions. Okay, so what I will do, I'm going to pick some questions, then I'm going to read it. Okay, so I'll read it, write the parameters, then I will solve them. So I hope that you are ready. Okay, so let's begin. Let's start with the very first example. Now the question goes this way. Two forces of 100 Newton. That simply means that F1 is 100 Newton, and of course 150 Newton. F2 is 150 Newton. Okay, acting simultaneously at a point. What is the resultant of these two forces if the angle theta is 45 degrees? Simple. Solution. So first of all, let's solve for the magnitude. So the magnitude of the resultant, applying cosine rule, we know already is f1 square plus f2 square, then plus 2f1 f2, then cos theta. Okay, so this is going to be equal to the square root of f1 is 100 square, 100 square, then plus 150 square, plus 2 times 100 times 150 cos 45. Okay, so this is going to be equal to, okay, let's calculate now. 150 square is 225. Okay, 150 square is, of course, it's going to be, okay, 150 square 22500, then plus 100 square, which of course is 10,000. All right, That's 32500. Now, if you multiply this, plus, of course, bracket open, 2 times 100, then times 150. Okay, then multiply by cos 45. If you use your calculator to evaluate cos 45, you're going to have 0.771 approximately. Okay, 0.71. Okay, then of course all right, equal to, so everything here is 75,100. So this is going to be this, the resultant is 75,100. So I have to find the square root of that. Square root of 75,100, that is 247 approximately. So 274 Newton. That is the resultant in magnitude. Okay. So now, of course, for the direction of the resultant alpha, you know what the formula? That's going to be the sine inverse of the resultant 27, sine inverse of f1, please pardon me, sine inverse of f1, which of course is 100. Okay, then multiply by sine 180 minus theta. That's going to be sine 180 minus 45. Okay, then divided by the resultant, which of course is 274. So let's work on this. So invariably now, alpha will be equal to, okay, so this is 180 minus 45 is 135. Then we evaluate the sine 135, 0.7071 approximately, then multiply that by 100, then divide it by 274, 0.2226 approximately. Okay, so that's going to be, in this case now, sine inverse of 0.26. All right, so let's evaluate that. So what you're going to do, we're going to do shift the sine inverse of that, which of course is 14. That's going to be 14 degrees. So I hope that is well understood. Okay, so that is number one question. So I will solve number two. So another example. Number two question. The question goes this way. Two forces act at an angle of 120 degrees. So the angle between the two forces is 120 degrees. The bigger force is 40 Newton. Okay? Let the bigger force be F1. Let it be 40 Newton. And the resultant is perpendicular. The resultant of the two forces, okay? The resultant of the two forces is perpendicular. Okay? Or let me write it in. For R is perpendicular to the smaller force, which of course is F2. Okay, so the question is, what is the smaller force? F2. So this question, to solve it, we have to draw the diagram. So the angle between the two forces is, of course, according to the question, is 120. So we have to represent that in a diagram. So this is F1 and this is F2. So applying the parallelogram law of vectors, okay, on this, of course, I'm going to have to complete the parallelogram. So you know very well that the resultant, according to this, is, of course, the angle is 120. All of this is 120. So the resultant will be the diagonal. Okay. The resultant will be the diagonal. Okay, let me draw that well. So invariably, this becomes the resultant. Oh, please pardon me. Okay, so this becomes the resultant actually. Let me. Okay, so now we are told that the resultant R is perpendicular to F is perpendicular to F2. Okay, according to the question, the resultant is perpendicular to the smaller force. Okay, okay, let the smallest force be F2. Okay, let the smaller force be F2, 40 Newton. The resultant is perpendicular to, let F1 be the, okay, okay, let me read the question again. Two forces act at an angle of 120 degrees. The bigger force is 40 Newton. Okay, the bigger force is 40 Newton. Okay, the bigger force is 40 Newton. All right, so let it be F2, which is 40 Newton. Okay, so now the resultant is perpendicular to the smaller force F1. So we're looking for the smaller force F1. Okay. Now, anyhow you want to actually draw it, but I know why I have to represent the smaller force by F1, of course, the bigger force, so that we are told that the resultant and the smaller force, okay, is actually perpendicular. That means this is perpendicular. Okay, so that means the angle between this the smaller force and the resultant is 90 degrees. So this invariably is 90 degrees. Okay, now don't forget that if this is 90 degrees, then invariably this angle now is going to be equal to 120 minus 90. And 120 minus 90 is 30 degrees. Okay, now if it is 30 degrees, then don't forget that from the parallelogram, all right, this side is still equal to F2, which of course is 40 Newton. Don't forget. So invariably, and looking at this alternate angle equal, if this angle right here is 30 degrees, this angle is also 30 degrees. And this is a right angle triangle. This triangle is actually a right angle triangle, so I can label it. Okay, so let me label it. Let this be O, let this be A, and let this be B, and of course C. So invariably, triangle OCB is actually a right angle triangle. So if it is a right angle triangle, we can actually apply trigonometrical ratio. So what is the ratio? The angle is 30 degrees and the opposite to the angle is F1. And the hypotenuse F2 is equal to 40 Newton. So we're going to use sine. So we're going to apply sine 30 degrees, which of course is opposite F1. That's what you're looking for. Divided by the hypotenuse, which is 40. So if we cross multiply, f1 is going to be equal to 40 sine 30 degrees. So f1 is equal to 40 sine 30 is 0.5. So that means f1 is 40 Newton. I hope that is well understood. F1 is 20 Newton, please pardon me. F1 is 20 Newton. All right. So let's look at more example. So the question goes this way. Find the magnitude of two forces. Find the magnitude of two forces such that if they act at right angle, their resultant is the square root of 10. Okay. So two forces, let the two forces be F1, of course, and F2. So we're looking for F1 and F2. F2. So according to the question, if these two forces, okay, if these two forces are at right angle to each other, if the two forces, that simply means by Pythagoras rule, F1 square plus F2 square, okay, of course it's going to be R square. This is used for two perpendicular forces. So if the two forces are perpendicular to each other, we are told that their resultant, the resultant is, according to the question, is the square root of 10. So that's going to be the resultant square, 10 square. So invariably enough, from what we have, F1 square plus F2 square, okay, square cancel square root, is equal to 10. Don't forget. All right. So let me just call this, let this be equation 1. Now, we are also told from the question, okay, but if the two forces act at an angle of 60 degrees, their resultant is the square root of 13. So invariably now, if F1 square plus F2 square, then plus 2F1 F2 cos 60 degrees, all right, then of course the resultant is 13. All right, of course you still have to square it. Square cancel square root. So what do we have here? Cos 60 is 0.5. 0.5 multiplied by 2 is 1. So I'm left with F1 F2. This is F1 square plus F2 square is equal to 13. Okay, equal to 13. So now let me call this equation 2. So how do we combine this equation to be able to, because we are looking for F1 and F2. Okay. Now, there's one relationship we are going to introduce. But look at before then, F1 square plus F2 square, as you can see, is 10. So if I bring it here, you discover that this is going to be 10 plus F1 F2, which of course is 13. So invariably F1 F2, if I make it the subject, that's going to be 13 minus 10, which of course is 3. Okay, so now I have another relationship. So invariably with what I have, so far so good, I can actually use it now to solve for F1 and F2. Okay, so let's look at F1 plus F2 square. The square of this. If you square this, you end up having F1 square plus F2 square. Okay, if you square this, if you actually expand this, right, you have F1 square plus 2F1 F2 plus F2 square when you expand this. Okay, now if that being the case, f1 square plus f2 square is already 10. Then, of course, 2 times f1, f2 is 3. That is 2 times 3. So that is going to give us f1 plus f2 all square. If we do the same, if we also do the same for f1 minus f2 square, f1 minus f2 all square, if you expand this, you will end up having f1 square. This time around, because of the minus, it will be minus 2f1, 2f1, f2. Alright, then of course, plus f2 square. Alright, so now with what we have, we know already, f1 square plus f2 square, we know that the is 10. Alright, then minus 2 times f1, f2, which of course is 3. 2 times 3. So invariably, I can combine these two now. Okay, I can combine these two. So how do I combine these two? The very first relationship here is 10 plus 2 times 3 is 16. 10 plus 16, that is 16. 10 plus 6, that is 16. Okay, so I can call this, let's say, equation 3. I can call this equation 4. So let's see how it goes. So invariably, this is going to be f1 plus f2. If I square root both sides, square will cancel square roots. So I'm left with f1 plus f2 is equal to 10 plus 16. Okay, and of course the square root of 16 is 4 if I square root both sides. All right, so don't forget this, still remember equation 3. If I do the same to this equation, so this is gonna be 10 minus 6. If I square root both sides, I'm gonna have, okay, this was minus, please pardon me, this was supposed to be minus. So if I square root both sides, I'm gonna have f1 minus f2, okay, square cancel square root, equal to the square root of 10 minus 6. 10 minus 6 is 4. The square root of 4 is 2. So this still remember equation 4. So now, solving equation 3 and equation 4 simultaneously, I can actually, I can get what I'm looking for. So how do I achieve that? So what I would do is I can eliminate. I can subtract equation 4 from equation 3. f1 minus f2 is going to give me 0. Then f2 minus into minus f2, that's going to be f2 plus f2, which of course is 2f2. Okay, 4 minus 2 is 2. So invariably f2 is going to be equal to 2 all over 2, which is 1. So now to solve for f1, I can decide to add. Okay, I can decide to add in order to eliminate. I can decide to add the two equations now to eliminate f2. If I add, I'm going to have f1 plus f1. That's going to give me 2f1. Okay, this one, I did this by, this is equation 3 minus equation 2. That's what I did here. So in this case now, what I'm doing here is equation 3. What I did here was equation 3 plus equation 4. So what I'm doing here now is going to be equation 3 minus equation 4. Okay, that's equation 3 minus equation 4. All right, so in this case, what I'm doing here now is going to be equation 3 plus equation 4. So if I do that, f1 plus f2 is 2f2. and of course plus F2 minus F3, that is 0. So 4 plus 2 is 6. So invariably F2 is going to be equal to 6 all over 2, which of course is 3 Newton. So F1, this is 2F1, okay? Please pardon my mistake. F1. So F1 is 3 Newton, F2 is 1 Newton. All right, so please take note of this. So this is a cosine rule, and of course parallelogram law of forces. So this is the very first analytical method of solving for resultant. So in the next video, we are going to look at the resolution of forces. All right, so see you in the next video. Thank you very much.